Hi, I'm Roberto Marquez. In this video, I demonstrate a user story for an automated, web-based testing framework. Tools used in this project include a source code repository, namely this one provided by github.com. And if you're interested in following along, this is the directory under that repository that contains the source code for this project. Java Standard Edition 8 or better is used as the programming language. Selenium WebDriver for Java version 3.11.0 is used to drive the web browser. Chrome Driver 2.7 is used for the Chrome driver. For Firefox, Gecko Driver version 0.23.0 is used. The NetBeans IDE was used to develop the software. And the application under test is provided by oneberto.com. Namely, this salary to rate converter is going to be tested to verify that this data is present. And later we'll have some interactive testing in the form of form submission to verify that we're getting correct values on this form here. In this section, I review the user stories implemented for this project. The first one is more of an epic in that it has some pretty big components to it. And it is listed here in who, what, why format, and is as follows. As a web automation developer, I need object-oriented test software, so the components are reused as much as possible to test applications. The following is listed for the acceptance criteria. The test software has runtime configuration for the following: URL under test, and browser type, and running in headless mode. And Maven profiles exist for specifying the browser, URL under test, and headless mode. And the default runtime configuration is to run in a desktop environment with the Firefox browser. And runtime configuration exists to execute tests in a desktop environment with the Chrome browser. And runtime configuration exists to execute tests in a headless environment with Chrome. And web automation tests use the page object design pattern to move between pages. And the continuous integration server runs the test software in a headless environment. The other user story implemented for this project is smaller and has the same format and is listed here. As a web automation developer, I need a method to take screenshots of the current page under test so that I can view what the application screen looks like at any point in the test. The acceptance criteria is listed as: the screenshot method is called at the test class level, and the screenshot is saved to the file system, and a post-processed hook exists to automatically screenshot at the end of each test method. In this segment of the video, I'll demonstrate the acceptance criteria for the main user story along with the acceptance criteria of the screenshot user story. So I'm going to go all the way up until this part and then cover these last two segments in the next segment. So the first thing to demonstrate is that the test software has runtime configuration for the following, which are the URL, browser type, and whether the application is running in headless mode. So we got to ask ourselves, what is the entry point for this application? And it is, in this case, the class salary to rate specification, which extends this class and makes use of Testng annotation test and declares this test method, which checks content, and also overrides the method subpath of its parent class to return this string. So this will be our entry point, and to demonstrate that these things are configured at runtime, we're going to go into the parent class, which is unit of work specification. And let's start at the bottom and see what's going on. And notice that we have a after test, which closes the driver. We have a end of test screenshot, which has to do with the screenshot that gets taken automatically at the end of a method, as indicated here by this annotation. An implementation of the screenshot software code that's going to capture the software. And here is the parent method of subpath, and so that's the one that this one overrides. And originally it'll just return empty string. And if we find the usages of this method, we'll see that it's used here, and the subpath is appended to the test URL for the web page under test. And so here is how we are driving the configuration of the URL, the browser type, and the headless mode by grabbing the test URL property from our properties object that is instantiated, that is loaded from this input stream that comes from a file named unit of work properties. And that unit of work properties also defines the WebDriver type, the WebDriver path key, the WebDriver path, and whether the WebDriver should run in headless mode. And then we have this this class that follows the Java Bean convention, in that it has getters and setters for the type, the driver path key, the driver path, and headless. And we'll get into how this is used in a bit, but I want to show how the unit of work properties file defines all of these properties and has placeholders to get tokenized at build time. So that demonstrates how the runtime configuration exists for the user, the URL, the browser, and running in headless mode. The next part of the acceptance criteria is that Maven profiles exist for specifying the browser URL under test and headless mode. So to demonstrate this, I need to go to the POM file for the project, and we can start at the top just to go over it in detail. And so by default, we have these properties, and our dependencies include Selenium for Java 3.14, like I mentioned in the beginning. And I forgot to mention that Testng is our unit test, or our testing framework for doing automated testing. And further down, we have specified that test resources should be filtered. By default, they're not, and we're using the default directory for our test resources. We're using the Maven failsafe plugin and specifying that this is our Testng configuration file. And then we'll be doing this at the verify goal and integration test goal. And for this part of the acceptance criteria, we have a Chrome profile, a Firefox profile, a headless profile, and a production profile that override the defaults that we saw at the top of the POM file. And so for Chrome, we're going to specify Chrome-specific things. Firefox is listed but doesn't override anything because it runs off of the default values. The headless profile overrides this property with the value of true, and the production profile specifies that the test URL is this value. So those are the profiles for getting the various types of configuration we need. The default runtime configuration is to run in a desktop environment with the Firefox browser. And first I want to demonstrate how we're using the IDE to build. And currently we have these values, which is production, specifying Chrome and Chrome driver specific things with headless. And I should have mentioned that this is the file that's under the target directory. So it's already been interpolated from this file, which is in our test resources directory. So if I go to the NetBeans customized profile screen, I'll show that the default config is now selected and activated. And you can tell because it's listed there. And if I build, we'll see it update with the default properties that are here in the POM file. Oops, I meant to show this right. So we should get this localhost with the default config. I'm going to say project build. Okay, so now we have the defaults for Firefox and a localhost, but I'm not running it locally right now. I'm going to go ahead and specify that we should be using the production profile, which is going to give us this URL for the test URL. I'm going to build again, and we should see this URL change. Whoops, I didn't change the profile. So it'll be production Firefox. I guess I meant to show this. The production Firefox has production Firefox properties enabled. And now if we build with this menu item, it should update this URL. Okay, so now we're set to run in desktop mode with Firefox, and I'm going to go to the test file and at the same time demonstrate that we're doing content verification, namely looking for this string in this string and that string in the body element of the page that gets brought up by WebDriver. So I'll say debug test file and rearrange the windows so that we can see more of what's going on. Okay, so there's our Firefox window. You can tell because it says it in the title of the screen. And we're here at this logging statement. So the next thing we should see is for it to come out in the console by stepping over, and it sure did. Test printing remove, and that was our test printing remove string. The next thing it's going to do is find the element, the body tag element by name, and grab all the text out of it and save it into that variable, which currently is not defined, but now we have it there. And the next thing we're going to do is define a target, which is consider earning 55 annually as a text, which corresponds to this text that's in the browser. And then we're going to assert that the body contains that text, which it does, so we don't get an error. And we're also going to verify that the default value of $26.42 appears on the screen, which corresponds to this here. So if I step over the assert, we shouldn't see an error, which we don't. And then the next thing it's going to, so this test method has ended, and it's going to automatically take a screenshot, which is how we end up in this method. And we'll see the end of screenshot being printed to the console. And then it'll run the method to execute the screenshot. But first I want to show how we can verify what's going on here by the timestamp. So earlier today at 3:41 I executed this test, and now we should see it update once I let the program run. So I'll let it go to the end of completion. It tells us that the test passed, and if I refresh this page we should see the timestamp update. which it updates to the current time. And there is our screenshot of the application under test. So this directory is just on my file system under the target directory for the application. You can see there's the POM, target, screenshots, and then there's a screenshot. So that pretty much demonstrates the screenshot user story in that the method is called at the test level class, which is our unit of work specification class that is extended by the salary to rate specification that has the unit test specified. The screenshot is saved to the file system as seen here, and the process hook exists to automatically take a screenshot at the end of each test, which is when we saw it debugging at the end of the test. I'm going to demonstrate the same thing, but with runtime configuration existing for desktop environment using the Chrome browser. And for that, I want to show the properties file getting updated with Chrome specific values here. And to do that, I'll change over to this profile, which is production Chrome, that has these two profiles activated. Okay, just to verify, we have production Chrome, and if I build it, we should see these values change. Okay, and in case you forgot, those values are driven by the POM file. And this profile. That's how we got Chrome, WebDriver Chrome, and this path into that file. So I'll run the test again, but this time it will be using Chrome. And so I'll come to this file and say debug test file. And this little debugging window comes up, but I usually just close it. I'm going to scoot it over so we can see on the left hand side the IDE. And again, we're at the point where it's going to print a debug statement. In the console, if I step over, it finds the body element and assigns the text to that variable. And looks for the target text of 55 annually, as seen here. Asserts that it's present. And then we come to the end of the test, taking a screenshot. And we'll go ahead and let it run to the end. We have successful build. And this time it should show 5:43 as the timestamp if I refresh the page, which it does. And on this one you can see that it didn't capture the full thing, so we know it was different. It's not the Firefox screen capture, it's the one for Chrome. The last part of the acceptance criteria covered in this segment is runtime configuration exists to execute tests in a headless environment with Chrome. Much like the last segment, but headless. So we will select the profile that specifies headless in this dialog here, which will be production Chrome headless. And activate that. And for brevity, I've already built it so that it's running as true. And we'll run the test again, but this time we won't see any browser open. We'll just be able to debug headless mode. And so we'll see this print statement go again like before if we step over. And then we'll find the body element as we did, look for the text, assert that the text is there. Same thing with the target to text. And if we let it run, we'll see that the screenshot is grabbed at the end of the test run. and the test passes. To verify the screenshot was taken, we should expect that instead of it saying 5:45, it says 6:38 if we refresh, which is the current time. And here is the screenshot, much like before. And I'll cover the rest of the last two segments in the next segment. In this segment of the video, I'll go over the last two items in the acceptance criteria, and in between that, I'm going to go in depth in form submission and validation. So the last two items are these two, and the first one is the web automation tests use page object design pattern to move between pages. So for this, we're going to go through and verify that once on this page that we can navigate here, as well as to the salary to rate page, and then back again using page objects. And the test for that is called income calculator navigation specification, and it extends that same base class so that we get automatic screen captures at the end of each test method, as well as pull runtime configuration out of that properties file. And this test, navigate all pages, is annotated again with the Testng test annotation. And let's run it with Chrome using the production URL. And I've already built that, so we can just debug test file and see what happens. In the meantime, I'll organize these windows so we can see what's going on left side to right side. Okay, you can see it's already at a breakpoint. And we're on the page, the target page. And if we step over, we should see the, excuse me, not step over. If we go to the variables, we can see that the unit of work page is calling salary to rate, navigate to salary to rate. And so let's see what happens in that method. So we'll step into, and this uses a page object to click on the rate navigation link. So let's go in there and see what happens. So the WebDriver is finding the link by ID, and so the ID is this value here, salary to rate. And if we inspect this item here, you can see that its ID is salary to rate link. So that's how it's finding that element and able to click on it. So if we step over this, whoops, if we step over that, it'll find the element and then click on it. And you saw on the right hand side it moved to the navigation, and it's returning a salary to rate page. So if we step up, it'll return that page. And if we step up again, we'll get that object back and move on to the next part of the navigation, which is to click on the rate to salary navigation, right? This one now. And same thing, we're going to step into it and see how it uses the driver to find an element by ID, rate to share link this time. And we'll step over. After I click this step over button on the right hand side, you'll see that it goes to the other page, and it's returning again a page object. And we'll step over and come to the back to the beginning of the page, which is to click on the income calculator navigation link, which is right here. And it's doing something very similar to the other two, which is to find the element by ID, in this case the income calculator link. And if we inspect this, you'll see that that is its ID, income calculator link. And we'll step over, click, and get back to the same page, return the page object. And we are asserting that the title is income calculators, which you see up here in the browser. And if that assertion passes, then our test is over. And we'll get a end of screenshot, or end of run screenshot. And I have that over here. Not that. Here. If we'll refresh this, this timestamp should change from 10:09 to 10:30 or so. We'll just go ahead and let it run. And we get successful tests. And if we refresh this page, this should update to 10:30. And that's what our screenshot looks like. So that was this part of the acceptance criteria, and now I'm going to move on to something that's not listed here but I think is very valuable, which is demonstrating form submission and verifying what the form returns is what we expect. For that test, we're going to use, yeah, I didn't mean to edit this page, so just let me correct that. For the form verification test, we're going to be using Java long to date specification class, which again extends the class that gives us free, not free, but automatic screenshots, as well as loading the runtime configuration. So let me just demonstrate what we're testing. So on this page, if we submit this form with nothing, you know, it tells us, hey, you've given a bad value. But if we supply a good value like 5 or something small, it'll convert it to the Unix epic date 1969. So that's what we're testing in this one, in this form submission. So again, let me arrange the windows so that we can see everything that's going on. Java to date long, and you'll notice that this one actually has 2 tests. It has 2 tests defined at least. So it has milliseconds to date, which corresponds to the form on the left, and then date to milliseconds, which isn't fully implemented yet, which corresponds to this one. But we're just testing milliseconds to date. So I have a breakpoint there, and I'm going to debug test file. And again, it's using the Chrome configuration, so that's the browser it'll use. And we're on the test page, which is expected. Ooh, I must not have set the breakpoint at the right spot because it's already taken a screenshot. There it goes. Now we're at the right spot. Okay. Even though there's a 9 here, let me just correct that. That's from the old test. Okay, so we're going to start off with 8 milliseconds, and we're going to, using our unit of work object, we're going to convert that, and then expect the converted date to contain 1969. So let's go into this method, and we're using a page object to set the milliseconds, which is this field here. And we're using find element by name, which is milliseconds, and that should be the value, the name of this field, which is right there. So we find that element, and then we convert the milliseconds to a string, and then we send that milliseconds, which currently has the value 8, as keystrokes to that text box. So once we do that, we should see this populate with 8, which it did. And we set the milliseconds, and if we step back out, we're going to submit the page. And stepping into that, we can see that we're finding the element by name, which is submit millis, and that corresponds to the ID on this convert button. Yeah, so there's the name submit millis and how it's able to find that web element and click on it, and you can see the date there. And if we step up, We'll return the results page and get the converted date, which is all of this here, and assert that it contains 1969, which is right there. And the same thing, we'll get a screenshot and notification that tests run and passed. And then we can check our screenshots. So there should be 2 new ones, which are these long to date and millis to date. There it is, and there's the second one. So that was a deeper dive into form submission and verification. The last part of the acceptance criteria is the continuous integration server runs the test software in a headless environment. I don't have a public Jenkins instance, so I'm going to demonstrate this on a private instance I have, and that is seen here. But first, I'm going to go into the actual configuration for this. So the whole time we've been running this, we've been using profiles to specify what values we're going to use at runtime. And this is pretty much how you would do it from the, and we were doing that via this drop down for the configurations, right? Headless, localhost, production with Chrome headless. But on the command line, that's a NetBeans thing. On the command line, it translates to passing Maven the -P option and specifying what profiles you want to use. So that here we're using Chrome, headless, production, and we're running the verify goal so that the Maven failsafe plugin activates. And then we're printing out the screenshot directory just so we can verify it took screenshots. Well, there's another way to verify, but I'll show that in the demonstration. And the only other thing that's going on in this Jenkins file is that it is cleaning the project before it compiles. So that is this right here. Whoops, I didn't mean to change that. Yeah, so first it cleans, and then it actually runs the tests. And this Jenkins file is located at the root of the directory, right at the same level as the POM. Okay, so let's go through it. So here I have a job already built for build web applications, verify web automation. And if we look at the configuration, you'll see there's nothing fancy going on other than it's a standard Jenkins pipeline that's pulling the configuration from source code, namely JIT, at this URL. And it's the Jenkins file. And when we run it, let me see, I'll run right now, and hopefully it'll be done by the time I just want to demonstrate the file stamps change and it works. So in the previous build 14, if you go to, whoops, I meant to show the console. You see that at the very end, all tests succeed. Sorry, all modules are built successfully. And at the very end, we ls on the screenshots directory, and we can see that the screenshots were taken. But to show you one of the advantages of using continuous integration and how it can speed up diagnosing problems is that all of that is available in the workspace of the pipeline. And so if you go to allocate node, you can get this workspace link, get to the workspace link, and this mirrors what's on GitHub, so it should look familiar by now. Under the web automation directory, we have a target directory. And under the target directory, we have the, well, we're supposed to have a screenshots directory, but it's not there. That's interesting. Alright, well, the last one finished. Let's see if it's there now. Don't make me a liar. Alright, here we go. I'm not sure why it didn't appear in the last build. It may flesh it out. But here are the screenshots, and you can see if I open them all individually. If it had failed, you'll get a screenshot and say, oh, you know, that this field was incorrectly populated. So that was for this last item in the acceptance criteria. I hope you enjoyed the demonstration of this user story, and I encourage you to explore the ideas presented in this web automation framework. Thanks for watching. Like and subscribe for more Selenium WebDriver automation content.